So far, I've been talking about ways of displaying different types of qualitative data. Now, we're going to be talking about displaying quantitative data with histograms that are both discrete and continuous, and with stem and leaf plots. So remember that quantitative variables are measured numerically, and with measures of quantitative variables, you can do things like add and subtract and multiply and divide and get a meaningful result. Age, weight, and temperature are all examples of quantitative variables. So we're going to construct histograms. A histogram is a bar graph that lists each measured category on the horizontal axis and the number of occurrences for each category on the vertical axis. The rectangles for each bar touch one another. Like for example, on top here we'd have a bar graph, and on the bottom we'd have a histogram. The only difference would be that the top is using qualitative data while the bottom is using quantitative data. So discrete histograms are created when dealing with discrete values on the horizontal axis, while continuous histograms are created when dealing with continuous values on the horizontal axis. So first we're going to create a discrete histogram. So here's my example. You ask 20 people to sample a new flavor of candy, then indicate how much they liked it on a scale from 1 to 5, with 5 being very tasty and 1 being tastes horrible. Here is a table of your results. So here I just have 20 different scores from 1 to 5. And we're going to first organize that into a frequency table like that. You see that we have 4 1s, 6 2s, 6 3s, 2 4s, and 2 5s. So it's just like creating a bar graph, except now it's a histogram and the bars are touching like that. And that is a histogram for discrete data. Now we want to create a continuous histogram, which is a bit more work. So in this example, imagine you light 200 matches and record how many seconds each match burns for until it goes out. So below is a table of your hypothetical results. So here we have 200 different numbers. They seem to be all between about 0 and 50. So there are no distinct categories here. Like before we had 1, 2, 3, 4, and 5. It was easy, but here we have many more values. In order to create, if we were to create a histogram, it would be giant. So what we're going to need to do is we're going to need to organize the data on the horizontal axis and create something called classes. Now a class is an interval of many values. For example, if you have a class from 1 to 10, it means this class covers all numbers ranging from 1 to 10. So a few definitions. The lower class limit is the smallest value within each class. The upper class limit is the largest value within each class. And the class width is the difference between consecutive lower class limits. So let me show you what I'm talking about. Imagine you have a frequency table like this, and you have it organized into intervals. This is just a sample. This isn't the example I was doing before. But you can see that, like for the first one, the lower class limit is 11, the upper class limit is 20, and then the next one, the lower class limit is 21, the upper class limit is 30, and our class widths are always 10, because whenever you're subtracting consecutive lower class limits, you end up with 10, as shown there. So for our data, how many classes should we include? Now there's really no hard answer for this. Usually you want to create between about 6 and 10, maybe between 6 and 12 classes. For this data I am going to just create 10 because that's the easiest. And what should the class width be? Well, if we're going to create 10 different classes and our values range from 0 to 50, that means our class width should be approximately 5. Just 50 divided by 10 is 5. So that's what I've done here. I've created intervals of 5, going from 1 to 5, 6 to 10, 11 to 15, all the way up to 46 to 50. And then I'm counting the frequency of values that fall within those ranges. And with that, I can now create a histogram with this continuous data, like so. Now, there's also another way of displaying this type of data, which is a stem and leaf plot. So imagine I recorded the rainfall in inches for the last 20 days, as shown in the table below. A stem and leaf plot for the above data would look like this, where the numbers on the left are the stems, and the number on the right are the leaves. So like for example, for 1 0, that would be 0.0. Then here in red I have another 0.0, a third 0.0, and a fourth 0.0. Now I have a 0.4 and a 0.6 and so on. It keeps going like that, 0.8, 0.9, all the way up to 2.7. So this is a way of displaying data that uses less space in that original table. So that's it for this chapter. We have discrete and continuous histograms, and in the continuous histograms you're going to have lower class limits, upper class limits, and class widths. And also, if you don't want to do that, there are stem and leaf plots.